Hello, we are 이동호, 강수승. We are 포항제철 High School second grade. We are going to talk about mathematical principle of Sepaktakraw. A common soccer ball is not round. It looks like a spear, but a soccer ball is a 32-hedron consisting of 12 regular pentagons and 20 regular hexagons. This means that it just looks round because it was inflated with air, but actually it is not a perfect sphere. Sepaktakraw, similar to soccer, is a game in which two teams kick the ball back and forth over a net and don't drop it to the ground. It started in the 15th and 16th centuries in South Asia. They bounce the ball with their heads or feet without using their hands or arms. Sepaktakraw balls, which had been made by weaving rattan, are made of special plastic. If you look the soccer ball and Sepaktakraw ball respectively, you can find two figures. A soccer ball has regular pentagons and regular hexagons, while a Sepaktakraw ball has triangles and regular pentagons. If you look at the shape of a soccer ball, it looks like a spear, but it has 32 hadron consisting of 12 regular pentagons and 20 regular hexagons. The soccer ball is a regular icosahedron. Each edge of the regular icosahedron is divided into 3 equal parts, and then dots which divide the edge into 3 equal parts are connected. You cut off the part containing the vertex, and now you get a regular pentagon. The part that was originally a regular triangle becomes a regular hexagon. This figure is truncated icosahedron. A soccer ball is a truncated icosahedron made of 12 regular pentagons and 20 regular hexagons. The structure of Sepaktakraw ball is similar to that of a soccer ball, which is truncated icosahedron and semi-regular polyhedrons. 3 overlapping straps make a regular triangle, and 5 overlapping straps make a regular pentagon. If you look at the shape of the overlapping straps, there is a regular pentagon next to each side of the triangle. Sepaktakraw is made of 12 regular pentagons and 20 regular triangles. Thus, the structure of the 32-hadron soccer ball and Sepaktakraw ball can be found through Euler's polyhedron formula. Euler found that convex polyhedron cannot be made with only hexagons or more polygons, and that triangles, squares, or pentagons are essential. It is also found that polyhedrons made of pentagons must have 12 pentagon shapes regardless of their figure. A regular polyhedron is a regular polygon each side of which is congruent, and the number of the sides at each vertex is the same. A regular tetrahedron, a regular hexahedron, a regular octahedron, and a regular icosahedron constitute the type of a regular polyhedron. Greek mathematician Euclid proved that there are only 5 regular polyhedrons. 3 regular triangles are gathered at one vertex. The sum of all the internal angles is 180 degrees, and it becomes a regular tetrahedron. In this way, we can make a regular octahedron with 4 regular triangles, and we can make a regular icosahedron with 5 regular triangles. But we cannot make a polyhedron with 6 regular triangles because the sum of all the internal angles is 360 degrees. 3 squares are gathered at one vertex. The sum of all the internal angles is 270 degrees, and it becomes a regular hexahedron. We can make only a regular hexahedron because the sum of all the internal angles is 360 degrees with 4 squares. In this way, 3 pentagons are gathered at one vertex, and we can make a regular dodecahedron. Also, we cannot make a polyhedron with 4 regular pentagons because the sum of all the internal angles is over 360 degrees. A regular hexagon is the same. In this way, Euclid proved that there are only 5 polyhedrons. Archimedes, an ancient Greek mathematician, discovered a special-shaped polyhedron. A new polyhedron was created by trisecting all sides of a regular triangle, one side of a regular tetrahedron, and cutting each side parallel to the bottom along a line that divides the sides into 3 equal parts. The polyhedron created by Archimedes is called Archimedes polyhedron. A semi-regular polyhedron is a convex polyhedron which has the same vertex figure but consists of 2 or more regular polygons. The types of semi-regular polyhedrons are as follows. One of the representative examples of semi-regular polyhedron is the soccer ball. The soccer ball is a truncated icosahedron, a semi-regular polyhedron that is most similar to the sphere. 3 regular hexagons cannot make a solid figure, so 1 regular pentagon and 2 regular hexagons in a vertex make the sum of all the internal angles 348 degrees. It can make a solid figure like a sphere. The structure in which hexagon and pentagon are connected is a stable and mysterious form that exists in the natural world. If you observe the virus under a microscope, you can see that it is connected with many hexagon and pentagon. It was also found that C16, a carbon allotrope attracting attention as a new material rich in applicability, is a structure made up of 12 regular pentagons and 20 regular hexagons like soccer balls. This structure is also applied in architecture. The geodesic dome, developed by American architect Buckminster Fuller, has exactly 12 pentagon shapes hidden regardless of its size. The architectural form of the geodesic dome is not only able to gain a larger space by using much less materials than traditional buildings, but also has a very strong characteristic without a single pillar.